Hello everyone, today let's look at Quantipus number 21, and this is another logical deduction type of brain teaser. Basically, you have 25 horses, each with a constant, unique, and unknown speed. You want to pick out the 3 fastest, and your only way to compare them is by racing up to 5 horses at a time. And in each race, you learn only the horses' finishing order, not their times, because if you knew their times, it would be a lot simpler, right? So what is the minimum number of races required to be certain you've found the top 3 horses? So some key things to note here, it says that they have constant speed, and that just means the horse is going to run the same speed no matter what. So there's objectively a fastest horse every time, and there's no variance coming into play, right? The fastest horse will always win the race. And they're unique, so that means no ties, and they have an unknown speed, which is what we are trying to figure out, or not the speed, but the relative speed with the other horses. And so we want to find the minimum number of races to be certain we found the top 3. We start with 25. Obviously, we know that we have to race every single horse at least once to understand where it ranks, right? So let's divide the horses up into 5 groups, right? If we have a decision tree, again, decision tree coming in here, with 25 horses, we know it's optimal to split into equal sized groups. And so we're going to split it into 5 groups of 5, which is convenient. Let's say group A, B, C, D, and E. We can call these heats as you do in a race. So now let's say in each group of 5, we had these horses race. So let's keep a total race tally over here. Total number of races. Well, we just had 5 heats. So let's say 1, 2, 3, 4, 5. Right, each race corresponding to our 5 heats. So in group A, we had 5 horses raced. Let's say they went like this, right? We had our first place in group A, and then let's say we had our second place in group A, denoted by A2, and then our third place all the way down to A5. And then in B, we have the same thing, right? This is B1, C1, D1, and E1, and they all have these dots represent the second place, third place, fourth place, and fifth place horses within their heats. Let me just draw these out like so. So now the clear and obvious thing to do, once we have the winners from each heat, let's race all these winners against each other. And now let's just say, for sake of argument, that this was the order. It doesn't actually matter, but let's just say that, and then B1, and then C1, and then D1, and then E1. So now we already know that we found our fastest horse, right? Because it is faster than all of the horses in its heat, and it's also faster than all of these horses, which in turn are faster than all the horses in their own heats. So A1 is obviously the fastest horse, and we did another race, so let's add that to our total number. And so A1's the fastest, but now the key thing is we have to find the top 3. So we need to find second and third place. So now A1 we know is definitely the first place horse, but how can we be sure about second place? Because what if everyone in A1 just ran the race faster than everyone in B1, right? What if second place is actually A2? For instance, this horse could have ran the race in 10 seconds, the fastest, and this one could have ran it in 11 seconds. B1 could have ran it in 13 seconds, and that could have been faster than all the other horses in the race. And we don't know just because all the fastest horses happen to be in the same heat. So clearly we're going to need another race, and the question is, which horses do we want to race to find second and third? So which horses even have a chance of being second and third, and which ones can we eliminate? Let's just start eliminating horses, right? Well, we already know that A1 is the fastest horse, so we do not need to race A1 anymore, right? We do not need to race A1. And similarly, let's look at, let's say D1, right? We already know D1 is slower than C1, B1, and A1, so there's no way that D1 could be in the top 3. Similarly with E1. Also, every single horse in their heat, D1 is faster than, right? So there's no way any of them could be in the top 3 either. So we can immediately eliminate all of these horses, right? So now let's keep going. Let's look at C1. Well, in the C heat, we know that all these horses were slower than C1, right? And C1 is slower than B1 and A1. So for all these horses, we have at least 3 horses ahead of them. So none of these horses could be in the top 3. So now let's take a look at the horses in B's heat, right? The second place horse here, then this horse, we don't know. So there's only 2 horses guaranteed to be faster than this one, right? So we can't eliminate it immediately. But these, on the other hand, there's going to be this horse that's faster than them, and B1 and A1. So we can eliminate eliminate these immediately. Now, finally, we look at A. A5 can't be it, right? Because there's 4 horses that are guaranteed to be faster than it. Same with this one. But for this horse, right, it could be 3rd place if everyone in the A heat is faster than everyone in all the other heats, right? So we can't eliminate this one either. But we can eliminate A1 because we already know it's the fastest horse. We don't need to race it again. So what are the horses that we're going to race next? You can see conveniently that there's only 5 of them, right? A2, A3, let's race A2, A3, B1, B2, right? This is B2 and C1. And once we get the 2 fastest from this race, we're going to know who got 2nd and 3rd place. So this is going to cost us another race, but as you can see, our final tally leaves us with 7.